Hello students, in this session we will discuss about the way of implementing array abstract data type and one more concept, sparse matrices. The first one, ArrayADT implementation. So to implement array abstract data type, first we define a class representation like class ArrayADT. Now int char 50 comma n. Now these are the data members. Here the data members are not specified with any access specified, hence those are treated as private data members. Now the possible member functions are void create, void insertion of int comma int deletion of int, void set of int comma int get of int, and void display operations. So here we are specifying different types of operations like create, insertion, deletion, set, get and display operations. Here now we discuss these operations one by one. First one, creation operation. So this procedure is used to create a single dimensional array with a specified number of elements. So this one, void ArrayADT scope resolution operator create. So here first we display a message as enter how many elements. Accept n value from the keyboard, and based on this n value we read those array elements as for I equivalent to 0, I less than n, I plus plus, c in cap I. So this function refers to creation of a single dimensional array with specified number of elements. Next operation, insertion. So this procedure inserts a new element at a specified position POS of the array K. This implementation point of view, for int I equivalent to n minus 1, I greater than or equivalent to POS minus 1, I minus minus, K of I plus 1 location is filled with K of I element, and then K of POS 1 position is filled with inserting element item. Then increment the number of elements as n equivalent to n plus 1. Deletion operation. Function removes the specified position element from the array K. The implementation point of view. First one, access the element from K of POS minus 1 location. Now shift the elements towards the left hand side with for I equivalent to POS minus 1, I less than or equivalent to n minus 2, I plus plus. Now K of I is filled with K of I plus 1 element. Now decrement number of elements as n equivalent to n minus 1. Now the deleted element is available in P, hence return P. Set function. So this procedure replaces the specified index position element with the new element item of the array. Here the simple logic, K of index equivalent to item. Get function. Function returns the specified index element of the array K. The simple logic, return K of index. And finally, display function. So display function is used to print all elements of the array K. Implementation. For int I equivalent to 0, I less than or equivalent to n minus 1, I plus plus, and simply print the element as cout K of I. So these are the different types of operations which are possible to implement with ArrayADT. Now we go for one specific application of arrays concept, sparse matrices. So what is meant by sparse matrix? A sparse matrix is a matrix representation of the given elements in which number of non-zero elements is less than the number of zero elements. That means the matrix has more number of zero elements. This example. Now observe this matrix format. Here it consists 5 rows and 6 columns. So 5 into 6, 30 elements are available. But here number of non-zero elements are 1, 2, 3, 4, 5, 6. Only 6 elements are available as non-zero and 24 zero elements are available. So number of zero elements are greater than the number of non-zero elements. This type of matrix is referred as sparse matrix. In mathematics point of view, different types of sparse matrices are available, where these are special kind of sparse matrices like diagonal matrices, lower triangle matrices, upper triangular matrices, etc. Here observe. Lower triangular matrix is a special kind of star matrix in which all entries above the main diagonal are zeros. This example. So this one main diagonal elements. So above this main diagonal all elements are zeros. This type of matrix is referred as lower triangular matrix. Upper triangular matrix is a special kind of star matrix in which all the entries below the main diagonal are zeros. This example. So this one main diagonal elements. So below this all elements are zeros. Another special matrix, diagonal matrix. It is a square matrix in which every element except the principal diagonal elements is 0. So here diagonal elements are non-zero elements and all remaining elements are zeros. Now, when we go for representation point of view, a sparse matrix can be represented either using a triplet format and linked list format. Here we discuss triplet format where it uses arrays. Let us one triplet representation of a sparse matrix. So in this format, here we consider only non-zero elements with their row and column index values. Here, when we are representing these elements, we use a triplet format like row, column and non-zero value. So when we design this format, so it is a table format that consists 3 columns like row, column and element values that represents where the number of non-zero elements and then each row and column of the non-zero entries. Now observe this example. Now consider this sparse matrix. Here 1, 2, 3, 4, 5, 6. So 6 non-zero elements are available. For this, the triplet representation should be not this format. So these 3 columns. Here the first row represents number of non-zero elements. Now this matrix consists 6 non-zero elements and matrix dimension is 5 rows and 6 columns. And then we specify the row number, column number and non-zero element. So 0th row, 4th column, non-zero element is 9. Row 1, column 1, non-zero element is 8. Row 2, column 0, non-zero element is 4. Row 2, column 3, non-zero element is 2. Row 3, column 5, non-zero element is 5. Row 4, column 2, non-zero element is 2. In such a way, a sparse matrix can be represented in terms of a triplet format. Thank you. Thank you one and all.